Hi, in this video I'm going to introduce you the applications of differential equation. Especially in this video I will talking about the application of first order linear differential equation with the types of separation of variables and the first order linear differential equation by using integrating factor in solving some equation. For example, in this case is involving electronics, right? Electronics and physics. So for example, so I'm not going to explain the physics here because as you know that the voltage here is defined, as you learn from physics, is V equals to IR, and for this is the capacitor. Capacitor is for charging, as you have a source electromotive force where it supply the energy. So it will be when the voltage drops across this capacitor, it will be involving charging, right? So which will be defined to be V to be equals to Q over C, right? As capacitance is charge over voltage. So this is the electromotive force, right? Your energy supply. So according to Kirchhoff law, E can be rewrite as IR, right? The voltage, the sum of the voltage drop across these two electronic device component, which is resistor and capacitor, will be IR plus with the voltage here Q over with C, right? And okay, you can ask your physics teachers and explain why is this, right? So as I know that in physics, I will be defined to be dq dt, the rate of change of charge. So it means that if I rearrange this, I will get a mathematical equation which is also a differential equation. Alright, 1 over C, I can write as 1 over CQ, which is equals to the energy supply, right? So according to Kirchhoff law, the voltage supply is equals to the voltage drops across the two electronic component here. After the switch is on, so this circuit will be running. There is a current, right? There is a current, and once there is a current, there is a charging for the capacitors until the capacitor is nearly charging, fully charging. So there will be a steady current, right? So this is what you study in physics, in the phenomena. But for mathematics, we're going to study how to getting that formula, right? How to getting that formula for the charge in the capacitor, right? The charge. We want to find the charge of the capacitor at time t, right? Q is the charge of the capacitor. Charge of the capacitor at time t, right? So we must have target. Our target here is to find the formula. We want to help the physicists, the physics, to find the formula for the charge of the capacitor at time t. Alright, we need to have a knowledge for differential equation. That's we call as the application of differential equation. Let's look at this equation. Okay, now I'm going to discuss this equation and how to solving this equation. Alright, let's see how to solve this equation. Alright, let's look at this. Can you try to see? And what is the application that you learn? You learn two, separation of variables and first order linear differential equation. So which is the type of equation that's suitable? For your information, I'm going to tell you. This you can apply both. You can apply separation of variables, or you can apply integrating factor for just solve it like a first order linear differential equation is okay. So in my video, I choose one of the method will be first order linear differential equation, because if I divide this whole thing by R, right? If I divide this whole thing by R, so I divide by R, I will have 1 over CRQ, which is equals to E over R. If you see carefully, this is actually a first order linear differential equation. First order linear equation can be written in this form: dy dx plus with pxy equals to qx, right? So if you compare dy dx, dq dt, you can see that this is your q and this is your t, right? And this is your q, y is q, right? And 1 over CR, 1 over CR is your px. and Qx is your E over R. If you compare, this is actually a first order linear differential equation which we can apply the integrating factor in solving this equation. That's very important. Before that, I have to tell you, if you have some knowledge of physics, you know that the capacitance, the resistance, the E are the constant, alright? Because why? They represent the capacitor. Okay, they represent the capacitor. The capacitance represent the capacitor, the particular capacitor in the circuit. The capacitor won't change, right? The capacitor won't change, so it will have a constant capacitance, and the resistor won't change in the circuit, so it will be resistant. There will be a fixed resistance, and this is the same battery, right? So they have a constant. All right, you have to identify the constant. So means according to here, all this is a constant, right? It's a constant. So remember this. So now I want to starting solving this equation. Hope you can enjoy. So the first here will be I want to find the integrating factor. All right, the integrating factor. So the finding the integrating factor, we usually divide by Vx. For this case, the x is t, right? Vt, and the formula is exponent integrate dt, right? What is your px, right? The integrating factor, we look at the px. The px is 1 over cr, right? 1 over cr. Okay, so 1 over cr, as 1 over cr is a constant, c is a constant, r is a constant, so we can take out the cr and we integrate 1 dt. So then we have e over 1 over cr, integrate 1 to dt, so it's t. So it means that your integrating factor in this case will be Vt equals to E 1 over CRT. Alright? Alright, let's see how to solving this. First step, you know that I have teach you all the steps during when I teach you about the first order linear differential equation. You're taking the integrating factor, you multiply to the differential equation, right? This one in the form of first order linear differential equation. So you multiply and you have E1 over CRT, right? 1 over CRT for dq dt plus with 1 over CR E 1 over CRT of Q equals to E over R E 1 over CRT. Right? If you see that, I have actually multiplied the integrating factor into all the term, right? Multiply both sides, each of the term with R1 over CRT, right? If you see. So, and this is your second step, right? Your third step will be, you're going to write this in the differential of the product form, right? Which is d dt. There will be a Q here, right? And this will be your integrating factor. Please refer to the video that when I solving about the first order linear differential equation, right? So this is the method. So 1 over CR, right? 1 over CR. So CRT is equals to the right hand side. E over R, E 1 over CRT. Alright, later I'm going to give you some examples and I'm not going to derive this all over again. Alright, so you try to understand here, this part here. So 1 over CRT. So this one, sir, why you can write this in this form? You try to apply UV to this case. E 1 over CRT, differentiate Q, dq dt, plus with, write back the Q, right? V, differentiate this one. Copy back, differentiate 1 over CRT, you will get 1 over CR, right? This is the function. This is the function after you differentiate this by using product rule, right? So as I can rewrite this back to this. So later on, I'm going to integrate both sides, right? I'm going to integrate both sides. E 1 over CRTQ dt, integrate E over R, E 1 over CRT dt. So what I'm doing now will be I actually integrating both sides. You try to look at this. Alright, I'm integrating this both sides. As you when you differentiate and you integrate at the same time, you will get back that integrand, right? 1 over CRT Q. This Q is changing. Q is changing. Q is not constant. Time is not constant. Why? Time change. Charge also change. Why? Because when you are actually, you have a circuit, right? You have a circuit. So the resistor and the capacitor, when you are supply energy, right? The capacitor initially means T0. So the capacitor, there are no charge. There are no source, no electric source here. So there are no charging. So once you switch on, they will start charging, right? So the charge will change. When the time, 1 minute, different charge. 2 minutes, different charge, okay? They will have different charge. So means that this is a Q in term. Means in this section here, actually we are trying to derive a formula for charge. Derive the formula for charge. We want to write the formula for charge in terms of time, alright? So, okay, you see what I'm doing now. So, which is equals to integrate. Remember, be sensitive to the variable here. So, this is a constant, right? I can take out the constant. 1 over CRT dt, right? I taken out the constant. So, as you see that, this one, to integrate exponent, right? Integrate exponent, 1 over CRT Q is equals to E over R, right? E over R. Integrate E2x, for example. This, just imagine this is a E, this is a 2x. So you will divide by 2, right? Once you integrate. So it means that you copy back this one, 1 over CRT. And this is the coefficient. So you can divide by the coefficient, 1 over CR. Right? Once you integrate, done, you add a constant, right? A constant C. So then you can see that 1 over CR. 1 over CR can rewrite. Okay, I go ahead and need some space here. So I will rewrite this to be E over 1 over CRT is equals to E over R. As 1 over CR go up, it will be changed, become CR over 1, right? Which is E 1 over CRT plus with a small c. This c is a constant, right? I just write it to be different. This is a constant after the integration. So as the r here can cancel off, so you will have 1 over CR T is equals to EC, right? EC E 1 over CRT plus with the constant, right? It's the constant. So later on, I'm going to find the, sorry, there is a Q here, right? There is a Q here. So how to find the constant? How to find this constant? We know that at time 0, right? When time 0, there are no charge. Before you switch on the circuit, there are no charge, right? No charge. So here will be 0. If this 0, this whole thing will be 0. And EC, this one, e to the power of t is 0. 0 multiplied with this, you are getting 0 plus with constant c. So it means that the constant c is the same as, this is 1 negative EC, right? Finally, we have get a formula where E 1 over CRT, right? 1 over CRT Q is equals to EC, E 1 over CRT, and the constant here is negative EC, right? Negative EC. So if I divide everything by E over 1 over CR, because I want Q as my formula, right? So the Q will be equals to EC, because I divide everything by 1 over E power 1 over CRT, and you divide by 1 over CRT, you're getting EC, right? 1. So minus with EC, as you divide with E to the power 1 over CRT, so it will become E negative 1 over CRT. So which is Q equals to EC. As you can factor out the EC, okay, it's a constant. So 1 minus with E negative 1 over CRT. So usually physics we say this is the full charge. Full charge means that after the circuit have fully charged, the capacitor have fully charged, this will be your charge, right? EC. Alright. Alright, let's see. This is a very powerful derivation, alright? You will study this in your physics matriculation or STPM. But physics will teach you this formula and they directly give you this formula, right? Then you memorize the formula. But actually, before you getting this formula, there is a great derivation, alright? So you have to understand this derivation, so you have complete knowledge of physics and mathematics. This is the power of study application of differential equation, alright? So then this will become the formula. This will become the formula for this charge, alright? For this series, the charge of the capacitor in terms of T. When time is 1, T is 1, charge. T is 2, different charge. Alright, so let's see how to write this in, we're going to sketch the graph for this and let you see what is the maximum charge that they can achieve after the time very long. Means you charge for very long, what is the final charge on the capacitor. Alright, okay, this is the formula that we derive. What's the formula about? This formula is about the charge on the capacitor, right? Capacitor is for charging, so you want to know the charge on the capacitor at time t. Before you switch on, right? Before you switch on, during the time 0, the charge is 0, right? The charge is 0, so you know that. So once you switch on, right? You switch on, there is a current flow through the circuit, right? So there is a voltage across the resistor and the capacitance, so it means they are charging, right? They are charging. So, but they won't keep charging, right? Until the current will be steady. When's the current will be steady? Alright, you will see that for this case here, so as the time very long, right? Very long period of time. What is mean by very long period of time? According to electronic, the long period of time may be in second, right? It's different. Okay, so if it's time approaching infinity, so what is the thing happen here will be the limits of the charge, means the limiting charge. So limits of the charge for Q is the same as the limits of the charge. The limits is a beautiful explanation in mathematics, but in normal language we said after a very long period of time, what happened to the charge? But in mathematics we just said limits of the charge. Okay, of EC 1 minus E negative 1 over CRT, right? As t approaching negative infinity, right? As t approaching positive infinity, so this number here, this variable here will end up to be 0. Do you know why? Because 1 over E, 1 over CRT, as t approaching infinity, so this whole thing will be approaching infinity. A number divided by infinity means that a very big value is very near to 0. Or we can say that this can be 0, alright? It's insignificant. So once this whole thing becomes 0, the charge on the capacitor will be EC. Nearly, we said EC, even though it's not really EC, alright? Because of the limiting current here, we assume this to be almost 0. So finally, as time approaching infinity, means that after a very long period of time, the charge will reaching EC. So if you sketch, so this is a deeper knowledge of mathematics. Okay, I'm not going to discuss this in this video. So as during time 0, the charge is 0, right? So once the time go longer period of time, the charge will reach a maximum charge. They will reach a maximum charge, a limiting charge here. So in mathematics there is a term for this, right? So this will be your EC, this charge. It will near to the charge, but it won't become that value. All right, it's just limiting. Alright, so this is the graph for this case here. So it means that the current actually is become stable. Once the charging is complete, almost complete, the current in the circuit will be steady. The current won't flow too high, right? According to mathematics, because it was steady. All right. So look at this. This will be the function of this formula here. So which is generated by mathematical knowledge, the differential equation. Right. In the next video, after this video, I'm going to explain how to calculate. If given a question, how we're going to solve by using the knowledge of differential equation.